Have you ever heard people say that because EVs are so heavy and have massive instant torque, their tires are done for after just 30,000 kilometers? But did you know, the Finnish tire giant Nokian tested this on a Tesla, and after driving 12,000 kilometers, the tread wear was actually less than a single millimeter. Based on this data, a set of tires can easily last 70,000 kilometers. So why are your EV tires wearing out so fast? It's not the car's fault at all. It's because your car's settings are completely wrong. In today's video, I'll first help you debunk 3 of the most hardcore, counterintuitive myths about EV tires, including why high-end cars can't block out tire noise, no matter how good their sound insulation is, why EVs can actually be much easier on tires than gas cars, and why you should absolutely never switch to truck tires just to save money. Next, I'll use real test data from the Finnish tire giant to run the numbers for you myself. Finally, I'll tell you exactly which key settings you need to adjust on your car to literally double your tire's lifespan, easily getting you 70,000 kilometers. Let's look at the first myth that people get confused about the most and feel the most wronged by. If a high-end EV has excellent cabin soundproofing, does that mean you don't need to spend extra money to buy those EV-specific silent tires with acoustic foam lined inside? The answer is the exact opposite. Precisely because your cabin soundproofing is extremely good, you urgently need this noise reduction gear even more. To understand this contradictory and counterintuitive phenomenon, we must first understand the physics of sound transmission. When a car is driving at high speeds, the noise that reaches your ears is mainly divided into 2 completely different transmission paths. The first type is called airborne noise, like the howling wind noise on the highway, or the rumbling engine sound when a large truck passes by. For this kind of mid to high frequency noise, the double-layer acoustic laminated glass common in modern luxury sedans and thick multi-layer door seals can block them out of the cabin perfectly. But the second type of noise isn't so easy to deal with. In engineering terms, it's called structure-borne noise. Imagine this: a car tire is actually like a donut filled with high-pressure air. Or, you can think of it as a huge soundbox of an acoustic guitar. When tires roll over the rough asphalt commonly found in Taiwan at high speeds, or drive over metal expansion joints on an overpass, the air inside the tire, due to continuous squeezing and vibration, generates low-frequency resonance at around 200 to 250 Hz. This kind of vibration cannot be blocked by glass or soundproofing cotton, because its transmission path goes right along the metal rim, transmits directly to the shock absorbers and suspension mechanisms, and then hits the main metal chassis of your car body with full force. Finally, the entire cabin becomes a massive resonance box, amplifying this low-frequency booming sound infinitely. When high-frequency wind noise inside your car is blocked by premium soundproofing, and the EV itself lacks an internal combustion engine's noise to act as white noise covering up chassis sounds, this low-frequency booming sensation, transmitting from deep within the frame and causing constant pressure on the eardrums, becomes extremely obvious. Over a long drive, it can even give passengers the illusion of motion sickness. And that layer of polyurethane acoustic foam that major tire manufacturers attach to the inside of EV silent tires is currently the only physical black magic in acoustics that can directly absorb this cavity resonance right at the source of the vibration. According to lab data, it reliably reduces the noise inside the cabin by 2 to 3 decibels. Do not underestimate these 3 decibels on the logarithmic scale of acoustics. Reducing by 3 decibels is equivalent to cutting the physical energy of the sound straight in half. That booming sensation that originally felt like a bass drum constantly beating near your ear instantly turns into a crisp rustling sound like a drizzle hitting the glass. The overall premium driving feel is absolutely a world of difference. Next, let's look at the second myth. Since EVs carry massive lithium battery modules, are incredibly heavy, and their motors have terrifyingly high instant torque, they are naturally ruthless tire-eating monsters. This statement actually only gets half the picture right if you treat every speed camera and every traffic light like a quarter-mile drag race, flooring the accelerator mercilessly every single time. Then forget about EVs. Even an ordinary internal combustion hot hatch with the most premium tires absolutely couldn't withstand that kind of abuse. But under normal daily driving conditions, EVs can actually be much easier on tires than gas cars. Why is that? It's thanks to the EV's nearly neurotic, ultra-high-speed electronic control system in the mechanical structure of a traditional gas car. When the engine burns fuel to generate power, this force has to be converted by the gearbox gears, transmitted by the drive shaft, and finally reaches the tires. At the moment of every gear shift or power connection, tiny mechanical jerks are inevitably generated. This jerking causes the tires to create micro-slips on the asphalt that are almost invisible to the naked eye. The engineering term is called micro-slipping. Don't underestimate this micro-slipping. When it happens during every single takeoff and acceleration, this is the real culprit, eating away the tread patterns on your rubber surface bit by bit. But the architecture of an EV is completely different. It relies on wires directly transmitting digital signals to the drive motor, with absolutely no complex mechanical shifting delays in between. Modern EV traction control systems, commonly known as anti-slip systems, can perform up to hundreds of lightning-fast calculations and current adjustments per second. This means that when the wheels are at the edge of traction on the road surface, in that fraction of a second just before micro-slipping occurs, the vehicle's computer has already cut excess output torque with extreme precision. This extremely linear power distribution, completely devoid of mechanical jerks, results in far less physical and necessary tearing and friction on the rubber than in a gas car. That's why, as long as you don't deliberately drive violently, an EV's tire lifespan will absolutely shatter your expectations. Next is the third myth, which is the most discussed on forums, yet the most likely to get you killed, since any EV easily weighs 2 tons, and monsters like the Cybertruck are pushing 3 tons. Can I just try to save money, pursue ultimate wear resistance, and go straight to a tire shop to install super heavy load light truck or small lorry tires? They're all just black rubber on the outside anyway, so as long as the rim size fits, shouldn't it be fine? If you have this thought, please drop it immediately. You absolutely must not have such a terrible idea. Truck tires, although physically completely capable of bearing 2 or 3 tons of weight, have rubber compounds and tread block designs that are fundamentally developed for commercial loads, off-road mud, and extreme wear resistance right from the start. This makes the rubber texture of truck tires extremely hard, with incredibly high rolling resistance. If you actually install truck tires on an EV that emphasizes aerodynamics and efficiency, you will instantly face 3 disastrous side effects. First, your battery range will suffer a direct and massive collapse. A car that could originally easily run 500 kilometers on a full charge, once fitted with truck tires due to the massive increase in rolling resistance, might take a 30% hit and only have around 300 kilometers left. The money you saved on a single tire will ironically plunge you into severe range anxiety every day, and you'll have to frequently spend money reporting to fast charging stations. Second, the overly hard rubber material of truck tires simply cannot grip the terrifying torque instantly unleashed by an EV. When you press the accelerator just a bit deeper taking off from a traffic light, you'll immediately hear the tires screaming and slipping like crazy. The traction control system will be forced to constantly intervene and cut power. Not only is this highly dangerous on rainy days, but the tires will also wear out abnormally due to continuous spinning and slipping, completely failing to achieve your expected wear-resistant results. Third, and what most directly affects your everyday driving experience, the weight of truck tires is astonishing. This will drastically increase the unsprung mass of the vehicle's suspension system. There's a famous ironclad rule in automotive engineering: 1 kilogram unsprung is 10 kilograms sprung. Overweight tires will make your shock absorbers unable to react in time when hitting potholes. The comfortable ride quality of an expensive luxury sedan will instantly turn into the feeling of driving a fully loaded delivery truck with extremely severe aftershock bouncing. It won't be long before the plastic trims inside the car start rattling with all sorts of strange noises. Therefore, what EVs truly need are Hull high-load spec tires specifically developed for them. The reason these tires are so expensive to manufacture is that tire makers must add aramid fibers used to make bulletproof vests into the extremely thin sidewall structure. This is commonly known as Kevlar material. This aerospace-grade material allows the tire to withstand extreme vehicle weight, while still maintaining ultra-thin sidewalls to ensure ultra-low rolling resistance, while simultaneously possessing sports car-level grip performance. This is the true crystallization of modern industrial technology. Never risk your life's safety just to save this bit of money. Having discussed so many profound physical principles, let's just let the most hardcore test data do the talking. For brand new passenger car tires sold on the general market, whether they are summer tires or all-season tires, their tread depth typically falls between 7 and 8 millimeters. To ensure water drainage and driving safety on rainy days, regulations in various countries clearly stipulate that the minimum wear indicator for tires is 1.6 millimeters. If the tread depth is lower than this number, not only will it fail vehicle inspections, but driving on the road is also illegal and extremely dangerous. In other words, for a new tire with an 8 millimeter depth, subtracting the 1.6 millimeter regulatory baseline means you have 6.4 millimeters of rubber thickness that can be normally worn down and used. The Finnish tire giant Nokian, to prove the point that EVs don't eat tires, had their R&D manager Mikko Liukula personally drive his own Tesla in the extremely freezing Nordic winter environment full of ice and snow, conducting a massive 1,200 kilometer road test. After the test ended, the engineering team used precision instruments to measure and found that the tread wear on this set of winter tires was shockingly far less than 1 millimeter. You need to pay attention to a crucial detail. Winter tires, to maintain grip at low temperatures, have a rubber compound that is typically much softer than the summer tires we use in Taiwan. It's just like chewing gum. Logically speaking, such soft tires should wear out even faster, even if we take a massive step back. And don't even say far less than 1 millimeter. Let's just use the most conservative estimate of a full 1 millimeter of wear to calculate. The 6.4 millimeters of wearable depth, multiplied by 12,000 kilometers, means this set of tires can physically achieve an ultimate lifespan of up to 76,800 kilometers. You have to realize, this isn't some overly optimistic data from a lab. It is a mathematical projection, derived from real-world road driving, experiencing countless starts and stops. Even if you are a highly safety-conscious owner who insists on the industry-recommended 3mm safety drainage line and decides to change tires early, then using a usable depth of 5mm multiplied by 12,000 kilometers, you can still solidly run for a full 60,000 kilometers. This data and mathematical projection completely debunk the nonsense on the internet that says EV tires can only last for 30,000 kilometers. So, here is today's main point. What exactly do we need to do in our daily driving to stretch an EV tire's lifespan to the absolute max of 70,000 kilometers? You absolutely do not need to spend money to modify any chassis hardware outside. Just the next time you get in the car, make these 3 crucial settings adjustments on the center screen. First, immediately switch your acceleration mode from Sport or Standard to Chill or Eco mode. This settings change uses the vehicle's underlying control software to limit the motor's current output curve during the initial stage of starting. It refines your takeoff torque to be as linear and smooth as a large displacement naturally aspirated gas car. When overtaking at high speeds, you can still enjoy the zero delay, on-demand acceleration feel of an EV, but it perfectly avoids the scenario where, in stop-and-go city traffic, every time you press the accelerator, the motor's instantly surging maximum torque brutally tears at your tire rubber against the asphalt. Just this setting alone can help you save at least 20% of unnecessary wear and tear. Second, please moderately adjust your regenerative braking strength. Many people new to EVs, in pursuit of the ultimate one-pedal driving experience, or trying to squeeze out a tiny bit more range, crank the regenerative braking to the maximum. But you might not have noticed the physics changes behind this. When you suddenly completely release the accelerator while driving at high speed, the motor instantly turns into a generator, and at that moment generating intense reverse drag force. The entire two-ton center of gravity of the car wildly shifts to the front. This massive downforce, coupled with the longitudinal friction from rapid deceleration, will cause extremely severe devastation to your two front wheels. If you want your tires to have a long life, without affecting braking safety and personal driving habits, please enter the settings menu and adjust regenerative braking to medium-low, or simply use the system's adaptive auto mode. This allows the vehicle to reduce sudden jerking when releasing the accelerator, buying more time for natural coasting. While in a coasting state, the tire neither has to bear the forward drive force of the motor, nor does it have to endure the reverse drag force of braking. It is in a free-rolling state with the lowest burden. This can vastly reduce unnecessary rubber consumption. Third, and the most basic yet most frequently overlooked point, please make sure to strictly maintain the high tire pressure recommended by the manufacturer. EVs are several hundred kilograms heavier than gas cars of the same size, so the contact area between the tread and the ground is extremely dependent on the air support force from the tire's sidewalls. If you arbitrarily lower the tire pressure because you're afraid the ride will feel too bouncy, the overweight vehicle body will directly flatten the sidewall, causing the tire to experience excessive flexing and deformation, and severe abnormal heat generation while rolling at high speeds. Not only will this substantially increase the fatal risk of high-speed blowouts, but it will also cause the tire shoulders on both sides to wear out rapidly, which is what mechanics often call two-sided abnormal wear. Conversely, as long as you cultivate good driving habits, regularly open the tire pressure monitoring page on the center screen every month, or check it yourself with a portable inflator, ensuring the cold tire pressure value is precisely maintained between 40 and 42 psi as indicated on the door frame. You can ensure the entire tread takes the force evenly, maximizing the lifespan of the rubber compound, as long as you thoroughly understand these engineering and physical characteristics hidden behind EVs, and strictly adjust these few software settings and driving habits. Your EV tires will absolutely never die prematurely after just 20 or 30,000 kilometers again. They will steadily accompany you for a full 70,000 kilometers, saving your wallet tens of thousands of dollars in massive expenses.